let's attempt problem 7 from winter 2022 midterm 1. So Zoe, a zoologist, is studying the population of giraffes near a lake. And she notices that the number is actually fluctuating in a sinusoidal manner. And just to make sure we agree on terminology, sinusoidal means it can either be sine or cosine. It really does not matter. And if you think about it, we can horizontally shift sine to get cosine. So there's really no difference between them if we are allowed to horizontally shift. Anyway, so it's a sinusoidal manner over a 24-hour cycle. So that's already telling us some important information. In particular, that the period of this graph is 24. And the giraffe population is reaching a minimum of 30 at 7 a.m. every day. And it's rising to a maximum of 50 at 7 p.m. every day. Okay? So we want to let g of t be a sinusoidal function, modeling the number of giraffes at the lake t hours after 6 a.m. So they're trying to trick us here. So t is the hours after 6 a.m. So for example, if I look at the maximum is 50, but you know this is happening at 7 p.m. And how many hours after 6 a.m. is 7 p.m.? Well, after 12 hours, it's 6 p.m., so one more hour. So this is happening at t equals to 13. And if you look at the minimum value, we know the minimum is 30. This is happening at 7 a.m. Well, 7 a.m. is 1 hour after 6 a.m. So you know the minimum is 30 at t equals to 1. Okay, so that seems to be all the information we have along with this period. And we wish to find equation of g of t. And they didn't specify whether it has to be sine or cosine, so we can use either one, I believe. So how do we find the formula? Well, to find equation of sine or cosine, there are really 4 different information you need to analyze. The first information is that you should know the period. And period is the time it takes for the entire graph to start repeating. So for example, if I look at the usual sine curve, so sine curve, this is starting at 0 and it ends at 2 pi. And if you look at sine curve, the portion from 0 to 2 pi is what's repeating over and over again. So this part repeats again, and so on. I mean, you don't even have to view it like this. For example, I can also take a look at the sine curve from here to here, from this maximum to the next maximum. This has a distance to 2 pi as well, as you can easily check. And you see that this part is also repeating over and over again for the entire sine curve. So the period really doesn't matter where you start. The entire point of the period is that if I just take a part of the graph from some point to that point plus 2 pi, that's actually repeating over and over again in the sine curve. Anyway, so you want the period. You know, if the period is 2 pi, you're going to have something like sine of x, or I guess here the input is t. And what if period changes? If period equals to pi, then you want something like sine of 2t. And the reason you want 2 times t is because when those signs start repeating, well, the sign starts repeating when t goes from 0 to 2 pi. And when I change t to 2t, now when t goes from 0 to pi, the thing inside is now going from 0 to 2 pi, right? So because I have this 2 times t only has to go from 0 to pi for the input into the sign to go from 0 to 2 pi. So if the period is pi, you want the expression to be sine of 2t. What about when the period, let's say, is 2023? So if you want the curve to repeat every 2023, then you want something like this. You want sine of 2 pi over 2023t. And the reason for this is when t now goes from 0 to 2023, the thing inside the sine, this entire quantity, is going from 0 to 2 pi over 2023 times 2023. So the entire thing is going from 0 to 2 pi. So it's repeating every 2023. So by using this kind of reasoning, you can easily find the coefficient of t inside the sine, given the period. The next bit of information that you may want is the amplitude. And the amplitude of the sine function is the distance from the midline. So if I draw this line that's halfway between maximum and minimum, this is called the midline. And in fact, this is the third information you need. So I'll add it right now. So if I know this midline, the amplitude is the distance from maximum to midline or minimum to midline. So this distance from here to here is exactly the amplitude. So if you think about sine, so if you think about the usual sine curve, here the amplitude is just 1. Now, what if I want to change the sine curve? So the amplitude is say like 3. So if I want to change the sine curve, so everything is the same except now the distance between the midline and maximum, this oscillation between this average value to maximum is now 3. Well, now you want 3 times the sine of t instead of the sine of t, because the sine of t used to output things between -1 and 1, and by multiplying by 3, that's stretching it vertically by a factor of 3. So now this entire thing is outputting things between -3 and 3. So the amplitude is really going to give you information about the coefficient in front of sine. The third kind of information here, as I mentioned, is the midline. And midline, just for the sine curve, is 0. 0 is the average between the maximum and minimum. And by changing the midline, you can shift this entire sine curve vertically up and down. So maybe you can, so maybe you can shift it to like this, or maybe you can shift it down like this. Everything stays the same, amplitude stays the same, but you can just move it vertically up and down, and that's what midline is gonna do. So for example, if I want to move the sine of t, up by 5, so then the midline is going to now be at 5. So you want something like sine of t, then add 5 to the entire thing. So adding 5 to the output of sine, this is exactly shifting the entire graph up by 5. So midline is giving you the vertical shift information. And the final thing you want is the horizontal shift. So let me put it in different color. The final thing you want is the data of horizontal shift. For example, if I want to move the entire sine curve, say like 3 to the right, well, now this is going to be sine of the quantity t minus 3. By replacing t with the quantity t minus 3, that's exactly moving 3 to the right, because here you have to plug in 0 to get sine of 0. Now I have to plug in 3 to get sine of 0 inside. So the x value corresponding to its output has shifted to the right by 3. So you want to do t minus 3. This can be confusing for some people. It's not t plus 3 for 3 to the right. So we want these kind of 4 information, and that's enough to find the equation of the sine curve. So let's go down one by one. Do we know the period? Yes, we do. They told us it was 24. So what that's telling us, we can just try this with sine. Doing it with cosine is similar. So it'll be sine of I guess you want 2 pi over 24t, because now when I plug in 24 into t, this entire thing becomes 2 pi over 24 times 24, so it becomes 2 pi. So this thing is now repeating every 24, because it takes t equals to 24 for the input inside sine to go from 0 to 2 pi. So you know this is what we have inside. What about the amplitude? Well, to find the amplitude, let's see what this graph looks like. So we have something like this. We are going to have some midline. The maximum is 50, minimum is 30. And when time is 1, we are at the minimum. And when time is 50, so when time is 13, we know you're at the maximum. So knowing what a sine curve looks like, this curve looks something like this. Obviously, what's going to happen after here is that you're going to go back down to midline, and then you're going to go to the minimum. And we see that this distance is 12. We have another 12. So this is 24. So this is one period of sine. And then this part starts repeating over and over and over again. Like this part of the graph can be pasted over and over and over again. But so we know this fact. But going back to the question of amplitude, well, to begin with, what is the midline? Well, midline is the average of 50 and 30. It's a number right between 50 and 30. So you can average 50 plus 30 over 2, or clearly in this case, the average is 40. So we know the midline is 40. So let me actually add that information at the end. So this is plus 40 thanks to the midline. And moreover, this is telling us that the amplitude, which is the distance from midline to maximum, is 10. So we know amplitude is 10, so we have 10 here. The final tricky part is how do you find the horizontal shift? Well, how you can view it is that if it's a regular sine curve, then it looks something like this. You start at your midline and you're increasing towards maximum, then you start decreasing and so on. So sine looks something like this. You start at t equals to 0. So at t equals to 0, you are at midline and it's increasing. So this is what sine looks like. And let's try to find a point on this graph where that's exactly happening. Well, that's happening right here, right in between t equals to 1 and t equals to 13, we are at a midline and we are increasing. So what is the coordinate of this point? Well, this is halfway between 1 and 13, so this is exactly a 7. So you know this is happening at time of 7. So what that's telling us is that you want to shift the entire sine curve to the right by 7. Because once we have this sort of the curve, everything is right except possibly the horizontal shift. You know, at 0 you're increasing at midline, and that's exactly happening at 7. So you want to shift the entire curve to the right by 7. And how you can do that, and some people tend to mess this up, make sure you put this in parentheses. You want to replace t by the quantity 7 minus t. Here 7 minus t is one thing, so you have to put it in the parentheses. So this is a correct answer if you're using sine. I guess I can quickly mention what changes if you use cosine. Well, if you use cosine, the amplitude, the period, and the midline, all of them stay the same. Except what changes for cosine is that at t equals to 0, you are at the maximum. So if I think of cosine, so it looks something like this. So this is for cosine. And for cosine at t equals to 0, you are at maximum. And what is that telling you? Well, so to shift cosine horizontally to get the graph you want, well, the maximum here is happening at time of 13. So if I'm shifting cosine instead of sine, now I want to shift it to the right by 13. So just to ensure that the maximum at 0 is now happening at 13. So if I'm using cosine, this should be t minus 13. And you can easily check, you can try graphing this on a graphing calculator, for example, that these two are actually exactly the same function. So it doesn't really matter which one you use, just make sure the horizontal shift is correct.